May 24, 1943. The North Atlantic was gray and empty to the naked eye, but to Admiral Karl Donitz it was a map of predictable outcomes. He commanded a weapon that did not need to win battles in the traditional sense, because it only needed to sink ships faster than the enemy could replace them. His crews called it a tonnage war, and they believed the arithmetic was finally on their side. Convoys still crossed the ocean, but they arrived smaller and more battered, and British survival still depended on what came through those waters. Donitz believed he had built a system that could not be stopped because it fed on distance weather darkness and fear. What he could not see was that another system had already surrounded his own, and it did not need to outsmart every submarine because it only needed to make the ocean lethal often enough. Karl Donitz was not a gambler who happened to wear a uniform. He was a professional who had studied the problem of maritime supply as a mathematical problem. Germany could not match the British Empire and later the United States ship for ship on the surface. Germany also could not break Britain by air power alone. Donitz believed the decisive lever was shipping because Britain lived on imports and because modern war consumed fuel, steel, food, and ammunition at industrial scale. If Britain could be starved, then every other Allied plan would collapse behind it. Donitz had learned from the First World War and from the limitations that had prevented a final German victory at sea. He believed submarines had been used too cautiously and too individually. He believed the future was coordination. A submarine alone might miss a convoy or fail to sink enough ships before escorts arrived. A group of submarines operating as a pack could force contact and then keep contact and then overwhelm defenses through repeated attacks. The concept was simple and brutal. Find the convoy. Shadow it. Call in other boats by radio. Attack at night on the surface where a submarine could move faster and see better than an escort could detect. Disappear before daylight and then repeat. This method depended on several assumptions that had once been realistic. It assumed the ocean was large enough that most convoys could not be protected by aircraft for the full crossing. It assumed that escorts were too few and too lightly equipped to keep a pack away from the convoy for long. It assumed that a submarine could approach on the surface at night and remain hard to detect. It assumed that a German commander could use radio to coordinate without being located fast enough to matter. It assumed that the enemy could not build and crew merchant ships at a rate that erased submarine success. Those assumptions were not absurd in 1940 and 1941. They were not even absurd in early 1942. German submarines ranged wider and sank more ships as the war expanded. The United States entered the war and offered new targets along the American coast. German boats attacked in waters that had little convoy discipline at first. The results looked like proof that the system worked. Ships burned within sight of shore. Tonnage losses rose. Insurance rates and political panic rose with them. Donitz could point to numbers and claim that the outcome was being decided not by heroic battleships, but by the slow suffocation of supply. The U-boat arm also had a culture that reinforced this confidence. Crews were trained to operate far from home in isolation under pressure. Commanders were selected for independence and aggression. The weapon itself rewarded patience and punished hesitation. A successful boat could return to base as a legend. A failed boat could vanish without a trace, and the ocean would not explain why. This created a belief in skill as fate. If a commander was good enough and bold enough, then the ocean would deliver targets, and the torpedoes would do the rest. Yet the U-boat war was never only about the crews. It was always about the environment that allowed those crews to function. Submarines needed bases and fuel, and trained men, and spare parts, and radios, and torpedoes, and weather information, and predictable shipping routes. They needed time to train new commanders and time to rotate crews. They needed a strategic picture that told them where convoys were likely to be. They needed the Atlantic to remain a place where a submarine could be invisible for long enough to strike. By 1943, the Atlantic was no longer that place. Dönitz still believed it was because he had learned to read the ocean as a hunting ground. The enemy had learned to read it as a controlled environment. The Battle of the Atlantic was not fought on a front line that could be drawn on a map. It was fought across thousands of miles of water where nothing looked like a battlefield until it was already on fire. Merchant ships carried grain oil vehicles, aircraft parts, ammunition, and men. Every convoy was a moving supply depot. Every sinking was not just a loss of steel, but a loss of time and labor and route capacity. Every successful crossing added strength to Britain and added weight to every future Allied offensive. Convoys were the first layer of defense and also the first layer of system. A ship alone was easy to kill. A group of ships could be defended by escort vessels and by coordinated procedures. Convoy speed was slow but predictable. Routes were planned to avoid known concentrations of submarines. Sailings were timed to match escort availability. Ships followed strict station-keeping rules. Radio discipline was enforced. Rescue ships and support groups were organized to reduce chaos after attacks. The escort forces themselves evolved from improvised protection into a dedicated industrial instrument. Early in the war, the Allies lacked enough destroyers and corvettes and escort vessels to cover every convoy. This created gaps and opportunities. It also created a fatal temptation for the U-boat arm. If a pack could force battle, then it could expect to find convoys with limited defenses. For a time, that was true. Submarines attacked at night and slipped away. Escorts often had limited detection equipment. Convoy commanders sometimes had to choose between chasing a contact and staying close to the merchant ships. The ocean favored the attacker because it was easier to hide than to search. Then the nature of the search changed. Detection technology improved and also became standardized. Radar appeared on more escort vessels, and it improved through successive sets. High-frequency direction finding, also known as HFDF, allowed escorts to take bearings on submarine radio transmissions and narrow the search area. This did not guarantee a kill, but it changed the geometry. A submarine that used radio to coordinate could now reveal itself in a way that the escort could exploit. Air power also changed the ocean itself. For much of the early war, there was an air gap in the mid-Atlantic, where shore-based aircraft could not provide coverage. This gap allowed submarines to operate with relative freedom during daylight and to coordinate attacks without constant fear from above. As long-range aircraft expanded and escort carriers entered service, the air gap began to close. A submarine on the surface became vulnerable far from land. A submarine forced underwater lost speed and situational awareness and battery life. A convoy with persistent air cover was not just better defended. It was a moving threat to the submarines that hunted it. The Allies also learned to fight the submarine war as a production and training problem. Escort crews were trained in anti-submarine tactics and drills until responses became routine. Support groups could be assigned to convoys and could also roam to reinforce threatened routes. Intelligence was integrated into routing decisions. The aim was not to win a dramatic battle, but to reduce losses and increase submarine attrition until the German system broke. This was the fundamental difference between the two approaches. Dönitz sought to win by sinking. The Allies sought to win by survival and replacement, and by slowly turning the ocean into a hostile medium for submarines. The first approach depended on the continued invisibility of U-boats. The second approach depended on making invisibility unreliable. By early 1943, both systems were fully engaged. German U-boat strength reached high operational levels, and packs deployed aggressively. Allied convoys continued to sail because the war required it. The result was a series of convoy battles that looked like tactical chaos but were actually system tests. Each battle measured whether the German method could still produce sinkings without unacceptable losses. Each battle measured whether the Allied method could reduce those sinkings while increasing submarine attrition. The ocean would not choose a side. The systems would. The winter of 1942 and the early months of 1943 were the last period when Dönitz could plausibly believe that the tonnage war might still decide the war. Submarine commanders reported successes, and convoys continued to suffer. Yet beneath the surface, the balance was changing because the Allies were adding layers faster than Germany could adapt. The U-boat method still relied on contact and concentration. A boat would find a convoy and transmit its position, and other boats would converge. The convoy would face repeated attacks over hours or days. Merchant ships would be hit, and escorts would struggle to keep the pack at bay. This was not a single battle. It was a process. If the pack could maintain contact, then it could create a steady rate of sinkings that added up to strategic effect. The Allied response attacked the process itself. HFDF meant the first transmission could lead escorts toward the shadowing submarine. Radar meant a surfaced U-boat could be detected at night at ranges that turned the old approach into a trap. Air patrols meant a boat that stayed surfaced too long risked sudden attack. Improved depth charges and ahead-throwing weapons increased the chance that an escort could convert contact into a kill rather than merely forcing a boat away. The battle for convoys became a battle of tempo. If escorts could respond fast enough, then the pack would be disrupted before it could assemble. If aircraft could arrive fast enough, then surfaced boats would be forced down. If the convoy could endure the first wave, then support groups could arrive and shift the balance. Dönitz needed time to mass boats. The Allies needed speed to deny that time. In late April 1943, convoy battles intensified and losses were still heavy. Yet U-boat losses also increased, and the effect on crews was severe. A submarine was not just a hull, it was a trained commander and a trained crew. Replacing a hull was hard. Replacing experience was harder. Each loss removed people who had learned to operate in the Atlantic and who could teach others. This created a hidden attrition that the tonnage war did not measure directly. In early May 1943, the pattern became undeniable in a sequence of convoy actions. Convoy ONS-5 became a critical example of the new balance. Merchant ships were lost and the convoy suffered. Yet the attacking force also suffered losses that would have been considered unacceptable earlier. The escorts fought with improved coordination and persistence. They used detection systems to maintain pressure and force submarines away from attack positions. They worked with aircraft to cover gaps and to punish boats that surfaced. Other convoys followed, and the pattern continued. Attacked convoys lost fewer ships than expected, and U-boats were sunk at a rising rate. Convoy SC-130 became another signal moment when U-boats suffered losses, and the convoy itself emerged without losing ships during those attacks. This was not luck. It was the result of layered defense and improved procedure, and the growing density of Allied assets. For the U-boat commanders at sea, the experience changed from hunting to survival. A surfaced approach at night could now be met by radar-directed gunfire. A radio call could now draw escorts. A daylight surface transit could now invite aircraft. A boat forced underwater could not keep up with a convoy and could not coordinate effectively. The ocean that had once offered invisibility now offered exposure. For Dönitz, the reports created a problem that doctrine could not solve easily. If submarines avoided radio, then they could not mass. If they avoided the surface, then they lost speed and awareness. If they attacked anyway, then losses rose. If they withdrew, then the tonnage war could not be won. The system that had produced success depended on behaviors that the Allied system had learned to punish. This is where the conflict became less about tactical skill and more about whether Germany could adapt its entire method quickly enough. Technical countermeasures existed in theory. New detection warning receivers and new tactics could be introduced, but these required production and training and time. The Allies were not waiting. They were adding escorts and aircraft and improved equipment continuously. The Atlantic was filling with sensors and weapons. In May 1943, the U-boat arm reached its peak in operational terms, but that peak concealed a structural cliff. More boats at sea did not guarantee more sinkings if each boat faced higher detection probability. At a certain point, the number of contacts did not matter because the environment itself became hostile. The more boats that entered that environment, the more losses would rise. This is what the month would prove. In May 1943, the Atlantic delivered the clearest verdict the tonnage war could receive. Allied shipping losses declined while U-boat losses surged. The month became known as Black May inside the German Navy because it represented a level of submarine attrition that the U-boat arm could not absorb. The critical fact was not simply that boats were being sunk. It was the rate and the distribution of those losses. Submarines were lost in convoy battles and also to air patrols. This meant danger existed at night and also in daylight. It meant danger existed near convoys and also on transit routes. It meant there was no safe rhythm to restore the old method. For a commander who measured war through sinkings, the numbers in May were a shock. German submarines lost scores of boats in that month across causes, and the operational impact was immediate. Each boat sunk removed a crew that had taken months to train, and a commander whose experience could not be replaced quickly. Meanwhile, Allied shipbuilding and repair continued, and convoys continued to sail. Dönitz faced the central dilemma of asymmetry. Every sinking mattered politically and materially to the Allies, but every submarine loss mattered strategically to Germany. Britain and the United States could replace merchant hulls and build escorts. Germany could build submarines but struggled to replace trained crews at the same quality and speed. The U-boat arm could not treat crews as expendable in the way the Soviet Union could treat infantry. Submarine warfare required specialists. The psychological effect of Black May was also severe. U-boat commanders reported increasing detection and increasing danger even when they followed procedure correctly. They reported sudden radar contacts at night and air attacks far from land. They reported that escorts hunted with greater persistence and coordination. They reported that the ocean itself felt occupied. This was the moment of realization. Dönitz had built a system that relied on the Atlantic being a space of uncertainty. The Allies had turned it into a space of surveillance. In such a space, the submarine was no longer a hunter by default. It was a target that occasionally found opportunity. On May 24, 1943, Dönitz ordered a temporary halt and withdrew most wolf packs from the North Atlantic. This decision was not surrender, but it was an admission. The method could not continue at that loss rate. The tonnage war could not be won if the submarines died faster than their results justified. The order marked the strategic turning point of the Battle of the Atlantic. The U-boats would return later with new tactics and new equipment. They would still sink ships, yet they would never regain the initiative that mattered. After Black May, the Atlantic belonged increasingly to the Allied system. To understand why Black May occurred, it is not enough to list technologies or battles. It must be understood as the emergence of a machine built from many parts that reinforced each other. One part was intelligence. Signals intelligence, known under the code name Ultra, gave the Allies access to high-level German communications once naval Enigma traffic could be read at key periods. This did not mean every message was always readable, and it did not mean every convoy could be routed perfectly. It did mean that the Allies increasingly possessed a strategic picture that reduced surprise and improved convoy routing and escort allocation. Information did not sink submarines by itself. It positioned forces so that submarines were more likely to be found and less likely to achieve concentration. Another part was direction finding. HFDF allowed escorts to take bearings on submarine transmissions and to respond quickly. The Wolfpack depended on radio. HFDF made radio dangerous. This forced German commanders into a trade-off that degraded their coordination. They could transmit and risk being hunted, or stay silent and fail to mass. Either choice reduced effectiveness. Another part was radar, and it spread through the escort fleet. Radar shifted night from a protective medium into a revealing one. A surfaced submarine that once relied on darkness could be detected and engaged. This forced submarines underwater and removed their surface speed advantage. Once underwater, a U-boat became slower and blinder and had to conserve battery power. A convoy that could force submarines underwater did not need to kill every boat. It needed to deny attack positions and deny coordination. Another part was air power and the closing of the mid-Atlantic air gap. Long-range aircraft and escort carriers extended coverage into areas that had once been free hunting grounds. Aircraft did not need to find every submarine. They needed to be present often enough that submarines could not linger on the surface and could not shadow safely. A single aircraft appearance could ruin a pack assembly by forcing boats down and breaking contact. In system terms, aircraft provided disruption as much as destruction. Another part was the escort fleet and its growth. More escorts meant convoys had thicker protection and could also support aggressive hunting tactics. Support groups could be assigned that were not tied to a single convoy and could reinforce threatened routes. This increased the density of anti-submarine forces in critical moments and reduced the effectiveness of massed U-boat attacks. It also increased the chance that a detected submarine would be prosecuted long enough to produce a kill. Another part was weapons and training. Depth charge tactics improved and equipment improved. Crews trained in coordinated attacks. They learned to maintain contact and to deny a boat the chance to escape. They learned to treat a convoy battle as a process and to stay disciplined. The goal was not dramatic destruction, but reliable reduction of risk. Yet the most decisive part was industrial replacement. The United States adopted standardized ship designs that could be built in huge numbers. Liberty ships became a symbol of this output, with 2710 built between 1941 and 1945. This did not mean sinkings did not hurt. It meant sinkings could be absorbed. The U-boat arm depended on the enemy being unable to replace losses. American industry made that premise increasingly false. Industrial production also applied to escorts aircraft radar sets, radios, ammunition, and the training institutions that produced crews. A ship was not just steel. It was engines crews. Fuel depots, repair yards, and procedures. The Allies expanded all of these in parallel. Germany could build submarines, but could not match the scale of escort production and the scale of aircraft coverage and the scale of merchant replacement at the same time. This is why Black May was not an accident of weather or a temporary tactical shift. It was the point at which the Allied system reached critical mass. Once enough escorts had radar, and enough convoys had air cover, and enough intelligence flowed into routing, and enough shipbuilding capacity existed to absorb losses, the Atlantic stopped being a solvable problem for submarines. For Dönitz, this was the end of the tonnage war as an independent path to victory. Sinking ships could still hurt the Allies and delay operations. It could not starve Britain into surrender or stop American buildup. the Atlantic lifeline held. The deeper truth is that the Allied system did not need perfection. It needed resilience. It needed to continue shipping while improving defenses faster than Germany could improve offense. In 1943, that is exactly what it did. After Black May, the Battle of the Atlantic continued, but its meaning changed. Convoys still sailed, and ships still sank, and sailors still died. Yet the strategic relationship had flipped. The Allies could now plan on the Atlantic being contested but manageable. This allowed long-term buildup of men and material in Britain, and it allowed sustained support to the Soviet Union through Arctic and Persian routes that complemented Atlantic supply. Germany still searched for counters. New technologies were introduced, and tactics evolved. But the core dilemma remained. Every adaptation required time and production and training, while the Allied system continued to expand. The U-boat fleet could still strike. It could no longer dictate. Black May also marked the end of a certain kind of warfare myth. The submarine had seemed like a weapon that could let a smaller industrial power defeat a larger one through asymmetric pressure. For a time, that myth had some truth because the ocean was vast and defensive systems were thin. Once the defense became layered and standardized and continuously reinforced, the asymmetry faded. The submarine became one more component in a war of machines and production. In later years, people would remember dramatic convoy battles and individual heroes. Those stories were real, and they mattered to those who lived them. But the outcome was decided by the interaction of systems. Ships were built faster than they could be sunk. Convoys were escorted with increasing density. Submarine radio calls became liabilities. Aircraft turned daylight into a threat. Radar turned night into a threat. Code-breaking turned secrecy into exposure. Training turned chaos into routine. This is why May 1943 was decisive. It was not the day a single U-boat commander made a mistake. It was the month when the Atlantic stopped being a place where a submarine fleet could live long enough to win. The German system required a permissive environment. The Allied system removed that environment. In modern war, courage can delay defeat, and skill can win engagements. Neither can outlast an enemy that replaces faster than you destroy. Black May proved that the decisive battlefield was not always a city or a ridgeline. Sometimes it was an ocean turned into a production line and a sensor network. The U-boat war did not end in May 1943. It ended as a realistic path to victory. After that, the Atlantic carried the weight of Allied industry toward Europe and toward the final campaigns that Germany could no longer prevent.